Okay guys, we're here with another video on this important proposition here. This proposition is very important for the area of mathematics, and it's a little mathematical fact we want to prove if we can. This proposition, we have the set of all negative numbers in OR. So we want to force those values to be only negative, so less than 0. And we got some theorems over here and some facts we want you to observe, and we're going to use that idea in the proof. So we want to show that negative a is a solution to that equation. Okay, so we need theorem 1 first to initiate that process, and some facts you might want to know here. Alright, so you got a less than x, right? And a less than x, and that'll be only our positive values. No, negative values, I'm sorry, negative values, right? We cannot go beyond 0. Because we don't want that in that case, right? Negative 1, negative 0.5, yes, but not 0, right? And why 0? We don't want 0 in this case. We only want the values less than 0. And if x equals 0, that annuls that, right? That's why we want only negative values. So that's some facts right there to help us to give us insight of the proof, in which I'm going to show shortly. So here, this is the proof, right? Theorem 1. Actually, and we also use the order property, right? But theorem 1 is sufficient because it tells us everything that we need to know to show that we only want negative values. So we just use what we learned. That's why theorem 1 is so important, because it's building up logically, right? This is the properties of math, that properties of the basic properties that we need to get to the next step, right? And that's why it's just true. So very important to understand this right here. Then we get to our conclusion, and our visual out there, right? It shows you why is that it's true, right? It gives us a better insight. So don't ever trust a picture. It just helps us understand the concept. And hence, right, we got all the set of all negative values, which is this right here. So this is just my proof of it, how we establish this. Okay, thank you guys for watching, and see you next video. Bye-bye.